Hey class, Mr. Husted here, back for another start to another exciting chapter of Geometry Notes. Today we're starting chapter 4, which is going to be all about triangles. Today we're going to talk about chapter 4, lesson 1, which is apply triangle sum properties. So just to kind of review a few key concepts here that you probably already know. When we classify triangles, we first classify them by their sides, and then we can classify them by their angles. To classify them by their sides, the first one is a scalene triangle. That's where no sides are congruent. Isosceles, we have two sides that are congruent, and equilateral when all three sides are congruent. Then when we classify them by angles, every triangle has two acute angles. Every triangle has two acute angles. It's that third angle, excuse me, it's that third angle that tells us what it is. If all three of them are acute, it's an acute triangle. If we have two acute angles and a right angle, it's a right triangle. Two acute angles and an obtuse angle, we have an obtuse triangle. If all three are the same, then we call that an equilateral, or I'm sorry, an equal angular triangle. Okay, so the first thing we're going to do here is just we're going to take a look here at this triangle, and we're going to classify it by its sides and then its angles. Okay, so if we notice here, and it may be a little hard to see, but if we look close enough, we can see that there are marks here and here, and therefore that means that we have two congruent sides, and when we have two congruent sides, that's known as an isosceles. And then when we look at our angles here, none of them are marked, so we don't know if they are all equal, but we can tell that they are all less than 90 degrees, so this would be an isosceles acute triangle. So again, just classifying by its sides, and then classifying by its angles. Okay? Nothing too difficult there, nothing you probably haven't seen before. Okay, let's flip over to the back side. Quick video today. Alright, again, something you probably already know, and that is that the sum of the interior angles, notice how this says interior angles meaning inside, so inside here. The sum of those angles is equal to 180 degrees. Okay, so any three-sided figure, any triangle that we deal with, the angles inside of that triangle add up to 180 degrees. That's the triangle sum theorem. Now the exterior angle theorem means that if we have an exterior angle, so notice how we have a triangle, and then this angle is on the outside, exterior meaning outside. The sum of this angle will be equal to this angle will be equal to the sum of the two non-adjacent interior angles. So if we're dealing with angle 1, we're going to be dealing with A and B. Measure 1 will be equal to A plus B. Okay, so let's put that into action here. Let's talk a little bit about example number 2. They want us to find the measure of JKM. So that's this angle right here. So by the exterior angle theorem, 2x minus 5 will be equal to the sum of those two non-adjacent angles. So that would be 2x minus 5 equal to x plus 70. So all we got to do is we got to get x by itself. So we're going to subtract x on both sides. That's going to give us 1x minus 5 equal to 70. We're going to add 5 to both sides, and we're going to get x equal to 75. Fortunately, we are not done there. It doesn't ask for the what is x, it asks for what is the measure of angle JKM. So what we're going to do is take 2x minus 5, and we're going to plug in 75. So 2 times 75 minus 5, 2 times 75 is 150, minus 5 will give us 145 degrees. Okay, so we're definitely getting back into a little bit more algebra here as we work through it. But obviously proofs will come back into play here a little bit. Okay, and then finally a corollary. This is basically just something that is implied. We know this. If we have 180 degrees in a triangle, and one of the angles is a right angle, that's 90 degrees. So that means for the remaining two angles, we have 90 degrees to work with. So what this states is that the acute angles of a right triangle are complementary. So if angle C is 90, A and B have to add up to 90 degrees. Okay, pretty self-explanatory. You could still plug in that 90 in there and use it, but they're just showing that you don't have to use that. All right, so last example here. The tile staircase shown forms a right triangle. So we'll say that this is our right angle right here. Okay, the measure of one acute angle in the triangle is twice the measure of the other. Find the measure of each acute angle. So what we need to do here, and it doesn't matter how we do this, we're going to say this is x, and it says the measure of one angle is twice the measure of the other, so that means this would be equal to 2x. So however you want to solve this, according to that corollary, all we have to do is say 2x plus x equals 90. If you want to use the triangle sum theorem where you do 2x plus 90 equals 180, you'll get the same answer. This is just trying to save you a step. Okay, so 2x plus x is 3x. When we take 90 divided by 3, we get x equal to 30. So our two missing angles, x will be 30 degrees, and 2x will be 60 degrees. So again, hopefully this is all just a bit of a refresher when it comes to triangles. This is, again, what this whole chapter is about triangles. So hopefully this is just jogging your memory a little bit, okay? If not, bring your questions with you to class. Copy those theorems and postulates into your postulum theorem page, and we will see you in class.